Hyperthyroidism was first described by a physician named Robert Graves. A condition now called Graves' disease is an autoimmune disease resulting in the overproduction of thyroid hormones. It affects 1 in every 200 people, one of those people being my mom.
My name is Rhonda. I was diagnosed with Graves' disease about 13 years ago at the age of 38.
The typical function of the thyroid gland in a healthy individual begins with a gland in the brain called the hypothalamus, which releases thyroid-releasing hormone, TRH. TRH stimulates the pituitary gland to release thyrotropin, also known as thyroid-stimulating hormone, TSH, which then targets the thyroid gland. TSH is a glycoprotein, a protein with sugars such as mannose and galactose attached, and a member of the cysteine knot growth factor superfamily. It also consists of 2 subunits, an alpha and a beta, that are linked by disulfide bonds. Between the 2 subunits there are 210 amino acids with 2 carboxylic acid terminal amino acid residues.
TSH is characterized by having several hairpin loops and a central cysteine knot. The thyroid-stimulating hormones from the pituitary then travel to the butterfly-shaped thyroid gland, which sits on the trachea. There are receptors on the thyroid gland that help the TSH bind to it. This binding stimulates the thyroid gland to release thyroid hormones T3 and T4. T3 and T4 are then carried through the bloodstream by proteins to various organs in the body. They increase metabolic rate and promote development of cells.
So where does this process go wrong and cause someone to develop hyperthyroidism? In an individual with Graves' disease, this process is only slightly different. The hypothalamus still communicates to the pituitary that it needs to release TSH. But rather than release TSH, the immune system, more particularly B cells, make an autoantibody called thyrotropin receptor antibodies, also known as thyroid-stimulating immunoglobulin, TSI, that attaches to thyroid cells. Shown here is the TSH receptor interacting with the thyroid-stimulating autoantibody, TSI. Chains A and B, shown in green and red, are the polypeptide TSI. They are linked together at a hinge with disulfide bonds. Chain B is a heavy chain with 228 residues, and chain A is a light chain with 216 residues. TSI cross-reacts with proteins in our own cells, and then targets the receptors on the thyroid gland. That receptor is a polypeptide chain C, which has 239 residues. Chain C binds to chains A and B through a series of 3 different domains. Shown in green are residues of the receptor that interact with TSI. Once TSI is attached to thyroid cells, it then activates the thyrotropin receptor, signaling the thyroid to increase its production of hormones. TSI acts like the TSH, causing the thyroid to overproduce the thyroid hormone. Thyroid hormones control many of the processes in the body, resulting in an array of symptoms.
Graves' disease cannot be cured, but there are things that can be done to inhibit the production of thyroid hormones in order to lessen the symptoms that occur due to the disease. One method is to take the medication methimazole, which interferes with the thyroid's use of iodine, a vital component in the production of thyroid hormones T3 and T4.